In the summer of the year 2003, a rocket lifted off from Cape Canaveral, Florida, carrying a machine unlike any other. Its destination was the Red Planet, Mars. On board was a six-wheeled rover built to survive for only 90 Martian days, or sols. But this rover would go on to defy every limit set for it, battling dust storms, freezing winters, and rugged alien terrain. It endured for over 6 Earth years. Its name was Spirit, a title that would come to define not only the rover's mission, but also the very essence of exploration itself: perseverance, courage, and resilience in the face of the unknown. But that name, Spirit, did not come from engineers or scientists. It came from the heart of a child. In a nationwide essay competition organized by NASA, a young girl named Sophie Collis, born in Siberia and adopted into a new life in the United States, wrote of the cold, dark nights in her orphanage and how she would look up at the stars, dreaming of flying among them. In America, she said, she had found hope, and in that hope, she gave a name to a machine destined to travel across worlds. That name was Spirit, a word that now belongs to one of the greatest tales of discovery in human history. When we think of rovers exploring distant planets, we often imagine something massive, complex, and towering with high-tech antennas. But Spirit, in truth, was modest in appearance. Weighing around 185 kilograms and roughly the size of a golf cart, it was a compact marvel of engineering. Small enough to be efficient, yet strong enough to endure the harsh conditions of an alien world. Its form followed a function carefully crafted for survival, resilience, and discovery. Spirit was not designed to dazzle with size. It was built to persist. At the heart of Spirit's ability to explore was its versatile toolkit. Mounted on a robotic arm were the Moose-Bauer spectrometer and the Alpha Particle X-ray spectrometer, two instruments that allowed the rover to identify the composition and mineralogy of Martian rocks and soils. Alongside these, a microscopic imager offered high-resolution close-ups of textures and particles, while a powerful rock abrasion tool, affectionately known as the RAT, enabled Spirit to grind away weathered surfaces and expose the fresh interiors of Martian rocks, never before seen by any eye, human or robotic. Spirit's body housed a set of panoramic and navigation cameras that served as its eyes on the Martian landscape. With them, it captured sweeping views of the dusty plains, distant hills, and rocky outcrops. Additional hazard avoidance cameras, or HazCams, allowed the rover to scan its immediate surroundings, ensuring each movement was calculated and safe. A miniature thermal emission spectrometer, perched on the rover's mast, played the role of a planetary scanner, helping to determine the thermal properties and potential origins of the rocks scattered across the planet's surface. Yet Spirit's engineering went beyond scientific curiosity. It was also a story of human memory. Incorporated into the rover's design were pieces of aluminum from the fallen World Trade Center, used to shield cables around the drill mechanisms, a quiet tribute embedded within a machine of exploration. Spirit was a symbol not only of what humanity could reach for in the future, but also of what it chose to remember from its past. a combination of cutting-edge science and solemn honor, journeying together across the stars. And of course, no machine is complete without a purpose. Spirit was born from NASA's Mars Exploration Rover program, a mission designed to answer 4 fundamental questions. Had life ever arisen on Mars? What was the planet's climate like? What did its geological history reveal? And could humans one day set foot there? Spirit was not merely a scout. It was the first whisper of a dream long held by humanity. A dream of reaching out across the void and asking the universe who else might be out there and where we ourselves are meant to go. In the early morning light of June the 10th, 2003, a Delta II rocket roared to life at Cape Canaveral, Florida. Its payload was Spirit, sealed tightly inside a protective shell. With a thunderous liftoff, it pierced through Earth's atmosphere and climbed into the quiet darkness of space. For most spacecraft, the launch is the most dangerous moment. But for Spirit, the true test was yet to come. Its journey to Mars would last nearly 7 Earth months, requiring flawless navigation, mid-course corrections, and a high-stakes descent onto an alien world. After entering a temporary parking orbit around Earth, the upper stage of the rocket fired one last time, sending Spirit on a heliocentric trajectory bound for Mars. But getting to the red planet is never as simple as aiming and flying straight. Tiny miscalculations can spell disaster millions of kilometers later. Over the course of its cruise, Spirit performed 4 trajectory correction maneuvers, precise bursts from onboard thrusters that gently nudged its path toward an exact arrival point. Every one of those maneuvers brought Spirit closer to its fate. By January the 4th, 2004, the spacecraft was on final approach. But while spaceflight is predictable, landing on Mars is not. Entering the atmosphere of the red planet is a terrifying plunge, compressed into mere minutes. Scientists call it the 6 minutes of terror. In that time, Spirit would need to decelerate from nearly 20,000 kilometers per hour to 0, with no help from humans, no room for error, and no second chances. Every movement had to be perfectly timed and flawlessly executed. "15 minutes before encountering the Martian atmosphere, Spirit separated from its cruise stage. Now protected only by a heat shield and aeroshell, it raced forward. As it slammed into the thin upper atmosphere, the friction generated temperatures above 1,600 degrees Celsius. Inside, the lander remained at room temperature, protected by the thermal barrier outside. At an altitude of about 7 kilometers, a supersonic parachute deployed, drastically reducing the spacecraft's velocity. Moments later, the heat shield was jettisoned, revealing the lander to the Martian air for the first time. Then, in a choreography of machines and milliseconds, the lander was lowered on a bridle beneath the parachute. Retro rockets fired, compensating for Mars's whisper-thin atmosphere, which is less than 1% the density of Earth's. Without those rockets, the parachute alone could never slow the descent in time. Finally, just seconds before impact, large airbags inflated around the lander like a cocoon, ready to absorb the final fall. At approximately 15 meters above the surface, the bridle was cut, and Spirit, encased in airbags, dropped freely to the ground. It struck the surface at a speed of about 14 meters per second, bouncing nearly 30 times across the rocky plain. Any one of those impacts could have torn the airbags or cracked the rover inside. But they held. After rolling and tumbling for almost 300 meters, Spirit finally came to rest, silent, intact, and alive, at the base of Gusev Crater. Spirit's precise landing was nothing short of miraculous. Though targeted for a wide area, it came to rest just 12 kilometers from its original aim point. The area where it landed would soon be named Columbia Memorial Station, in honor of the 7 astronauts lost in the Space Shuttle Columbia tragedy 1 year earlier. As the airbags deflated and the petals of the lander unfolded like a mechanical flower, Spirit awakened. A new chapter was about to begin. Not just for the rover, but for our understanding of Mars. From its perch in the dusty plains, Spirit immediately began transmitting data back to Earth through 2 orbiters already circling Mars, Mars Global Surveyor and Mars Odyssey. The very first images sent by Spirit were panoramic views of its surroundings, rocks, hills, and the rust-colored Martian soil stretching out beneath a salmon sky. These images, stitched together from black and white frames, passed through multiple filters, became the highest resolution color images ever taken on another planet at the time. Spirit had not just arrived, it had opened its eyes and was ready to explore. When Spirit opened its electronic eyes for the first time on the Martian surface, it saw a world both alien and eerily familiar. Stretching out in all directions was a terrain of dusty plains, scattered with rocks, hills on the horizon, and a soft orange sky overhead. The first images it sent home were captured by its panoramic cameras. A grid of high-resolution black and white photos passed through various color filters, later stitched together to form a breathtaking mosaic. With those first transmissions, humanity saw Mars not as a distant point of light in the night sky, but as a place, real, tangible, and waiting to be explored. Spirit's landing site lay within a vast basin known as Gusev Crater, a circular depression nearly 160 kilometers in diameter. From orbit, scientists had long suspected that Gusev may have once held a lake, its basin fed by an ancient outflow channel called Ma'adim Vallis. Theories suggested that if water ever pooled here, it may have left behind sediments, minerals, and even signs of life from a wetter Martian past. It was for this very reason that Gusev was selected as the rover's target, a prime location to begin the search for clues about water and habitability. The landscape around Spirit was peppered with rocky features and small hills, later named after the astronauts who perished in the Columbia Space Shuttle disaster. Among them were Anderson Hill, Clark Hill, McCool Hill, and Husband Hill. Each hill carried more than just a name. They carried memory, legacy, and meaning. Near the lander, Spirit spotted a shallow depression that came to be known as Sleepy Hollow. Its unusual shape intrigued scientists, who believed it could reveal information about the subsurface structure of Mars. Within days of landing, Spirit began rolling cautiously toward it. Using its hazard avoidance cameras and navigation systems, Spirit carefully maneuvered just over 10 meters to the rim of Sleepy Hollow. From there, it captured additional panoramic views and surveyed nearby rocks. The precision with which it operated was a triumph of remote engineering. With every image it returned, mission scientists back on Earth could analyze textures, shadows, and soil distribution. They searched for anything that might hint at water-altered materials, the holy grail of Martian exploration. Even before its first sample, Spirit was already shaping the science of another world. Columbia Memorial Station was more than a landing site. It became Spirit's base of operations, a symbolic link between two missions that shared the same spirit of exploration. As Spirit continued to scan the crater floor, NASA's engineers took pride not only in the rover's flawless performance, but also in the clarity of its vision. The quality of the images surpassed expectations, revealing fine-grained soils, angular rocks, and distant ridgelines etched by time. Spirit had only just arrived, and already it had begun to unravel the story written in the dust of Gusev Crater. On its 17th day on Mars, or Sol 17, Spirit suddenly fell silent. One moment, it was operating normally, sending data and images from the surface of Gusev Crater. The next, all communication from the rover ceased. NASA's Deep Space Network, which had been in constant contact, received nothing. For a machine hundreds of millions of kilometers away, silence is terrifying. The rover team on Earth was left in a state of confusion, anxiety, and dread. They had no idea whether Spirit had suffered a catastrophic failure, entered a fault state, or simply gone dark without warning. Then, the following day, a faint beacon broke through the silence. A simple, unmodulated tone, like a heartbeat. Spirit was alive. The signal meant the rover was still powered and able to receive commands, but it had entered a state known as fault mode. In this state, Spirit ignored all but the most basic commands, responding only intermittently. The team's relief was tempered by concern. Fault mode could result from a number of critical issues, including hardware damage or severe software corruption. The urgency was real. If not diagnosed and resolved quickly, Spirit could overheat, drain its batteries, or suffer irreversible harm. Engineers began sending diagnostic commands, hoping to coax the rover into revealing the nature of its malfunction. Soon, a picture began to form. Spirit's onboard systems had failed to enter sleep mode correctly, which meant it had been running continuously through the freezing Martian night, draining power and generating excess heat. The system had grown unstable and confused, misinterpreting its condition and entering a reboot loop. Most troubling of all, Spirit began to ignore direct shutdown commands, the kind meant to preserve its life. If the behavior continued, it could spell the end of the mission. One hypothesis pointed to a problem with Spirit's flash memory. This onboard memory system, critical for storing mission data, appeared to be overloaded or corrupted. Engineers theorized that the rover was rebooting repeatedly every time it tried to access this failing system. Fortunately, Spirit had a backup method to bypass the flash memory entirely and boot from RAM. NASA's team made a daring decision to trigger this alternative boot sequence, a risky move, but one that worked. Spirit successfully started up without relying on its compromised storage, breaking the vicious reboot cycle. Once stabilized, Spirit began sending engineering data that confirmed another source of trouble. The rover's file system was overburdened with thousands of redundant data files, leftovers from its cruise phase to Mars. Most of these were no longer needed. Over the next several sols, the team remotely deleted the excess files, freeing critical memory. They also reformatted the flash storage and restored system health. Finally, Spirit was able to enter sleep mode properly, regulate its thermal systems, and resume normal operation. It was a comeback not just of machinery, but of human persistence. By Sol 32, Spirit was once again fully functional. It was rolling across the surface, taking images, and analyzing rocks, as if nothing had happened. But for the team at NASA, those 15 sols of silence were among the most intense days of their careers. In that time, they had faced the real possibility of mission failure and had pushed the limits of their engineering knowledge to bring a silent rover back from the edge. Spirit had proven, even early in its mission, that survival on Mars was not just about design. It was about resilience, problem solving, and the quiet, unwavering determination to continue. Once Spirit had fully recovered, its mission could truly begin. With its instruments checked and systems restored, the rover turned its attention to the surface of Mars, not just to observe, but to uncover. Scattered across the plains of Gusev Crater were countless rocks, silent remnants of the planet's geological history. Among them was a football-sized target, located just a few meters from the lander. Its name was Adirondack. Unlike many rocks nearby, Adirondack had a flat, dust-free surface, an ideal candidate for Spirit's first close-up scientific investigation. Before Spirit could begin any physical interaction, it used its tools to observe from a distance. The microscopic imager captured detailed close-ups of Adirondack's surface texture, revealing a rough, crystalline structure. The Moosbauer spectrometer and alpha particle X-ray spectrometer analyzed its chemical composition, suggesting the presence of magnetite, olivine, and pyroxene, minerals often found in volcanic basalt on Earth. These early results hinted that Adirondack was not just an ordinary rock, but potentially a time capsule from a volcanic past, possibly shaped by water long ago. But surface scans could only reveal so much. To truly understand what lay beneath the weathered exterior, Spirit deployed one of its most remarkable instruments, the Rock Abrasion Tool, or RAT. About the size of a soda can, the RAT was designed to grind away the outermost layer of Martian rock. Using a spinning wheel coated in industrial-grade diamond dust, it could carve out a circular hole 5 millimeters deep and nearly 5 centimeters wide. This allowed Spirit's other instruments to analyze fresh, unaltered rock that had not been exposed to the Martian atmosphere for millions, perhaps billions, of years. On Sol 34, Spirit performed the first ever rock abrasion on another planet. The rat ground into Adirondack with precision, removing its dusty surface and exposing pristine material underneath. It was a historic moment. For the first time, humanity had touched and manipulated the deep interior of a rock on another world. Follow-up measurements on the newly exposed surface confirmed that Adirondack was indeed volcanic basalt. What intrigued scientists, however, was the possibility that thin films of water had once interacted with the rock, subtly altering its mineral structure. Though the signs were faint, they were meaningful. Adirondack was easier to grind than similar basalt rocks on Earth, a subtle clue that it might have undergone chemical changes from exposure to liquid. It was not definitive proof of past water, but it was a strong suggestion. For a mission just beginning, it was an encouraging sign. Spirit had already fulfilled a key part of its objective, finding rocks that offered evidence of ancient geological processes and possibly ancient water. Adirondack was only the beginning, but it told scientists that Mars still had stories left to tell, written deep in stone. With Adirondack explored and its secrets revealed, Spirit did not linger. The Martian landscape stretched wide in every direction, and its next destination lay just beyond. That place was a dark volcanic rock named Humphrey. Standing nearly 60 centimeters tall, it towered like a solitary monument against the rust-colored soil. At first glance, it appeared solid and unremarkable, but within its structure lay something extraordinary: light-colored veins that snaked through the rock's core. To the trained eyes of planetary geologists, this was a tantalizing sign of a story written not only in stone, but in water. When Spirit used its rock abrasion tool on Humphrey, it uncovered these bright materials just beneath the surface. They appeared in cracks and crevices, suggesting that water had once flowed through the rock, leaving behind crystallized minerals as it evaporated or cooled. Such features can form only in the presence of liquid. Though Mars today is dry and cold, Humphrey hinted at a time when water was more than vapor or frost. It was evidence, not yet of life, but of the conditions that might once have supported it. For Spirit, this was a major scientific step forward. From Humphrey, Spirit was commanded to investigate Bonneville Crater, an impact site not far from the landing area. Bonneville measured just over 200 meters in diameter and 14 meters deep, with a rim that rose about 6 meters above the plains. Scientists hoped that its interior might expose older layers of rock, perhaps revealing signs of subsurface water or past geologic events. As Spirit approached the edge, it imaged the crater from above, capturing detailed panoramas of the terrain. But once there, it found something unexpected, a scene that was, geologically speaking, rather dull. The interior of Bonneville was littered with loose debris and lacked exposed bedrock. There were no unique rock formations, no layered walls, no intriguing mineral signatures. It seemed that the crater had formed more recently and had not experienced much erosion. Some scientists believed it might be a secondary crater created by the debris from a larger, more distant impact. Spirit's heat shield, jettisoned during descent, lay nearby, a reminder of the rover's dramatic arrival. Yet despite the scientific hopes, Bonneville held few secrets. It was time for Spirit to move on toward a destination of far greater promise. In the distance, the Columbia Hills beckoned, a series of ancient, uplifted ridges that may have recorded some of the oldest geologic activity in Gusev Crater. From orbit, these hills appeared layered and complex, and their higher elevations might offer clues to Mars's deeper past. To get there, Spirit would have to travel across a wide plain of sand and rock. Along the way, it passed smaller craters like La Hontan, a bowl just over 50 meters across. While not scientifically groundbreaking, these features reminded the mission team of the rugged, uncharted nature of the Martian surface. As Spirit neared the base of the Columbia Hills, the terrain became steeper and more challenging. The rover's right front wheel began drawing more electrical current than expected, a possible sign of mechanical resistance or wear. Engineers feared that dust, debris, or thickened lubricant could be impeding movement. The team made adjustments to conserve energy and reduce strain, eventually limiting use of the troubled wheel. Even as the Martian landscape became more demanding, Spirit pressed on. Its goal was clear: reach the ancient hills, climb their slopes, and uncover what Mars had buried deep in time. As Spirit approached the Columbia Hills, signs of age began to show. The Martian terrain was becoming more complex, and the demands on the rover were growing. One day, engineers noticed something unusual. The right front wheel was consuming nearly 3 times more electrical current than the others. This could mean that the wheel was experiencing internal friction, or worse, was partially seized. Spirit was facing a mechanical challenge that could threaten its ability to climb, maneuver, or even continue its mission. On Earth, a technician could simply take a look. On Mars, it was a mystery that had to be solved remotely through ingenuity and code. Engineers suspected 2 possible causes: debris lodged inside the wheel housing, or thickened lubricant no longer flowing properly in the extreme cold. Spirit was equipped with small heaters near the wheels, designed for this exact possibility, to warm internal parts and keep the motors running. But no one knew if those heaters would help in time. To protect the drive system, the team made a decision. Spirit would continue using only 5 wheels whenever possible, reducing strain on the malfunctioning one. The damaged wheel would roll passively, being dragged behind the rover during longer traverses. To address the rover's growing list of concerns, NASA initiated a full-scale diagnostic and maintenance period, a kind of mechanical tune-up designed to prepare Spirit for the kilometers still ahead. The team recalibrated the hazard avoidance cameras, which had developed slight misalignments that caused the rover to misjudge target distances by several centimeters. Engineers used a series of test images and carefully coordinated arm movements to realign the targeting system. They also ran diagnostics on the wheels, verified thermal controls, and tested Spirit's ability to perform visual odometry, a method of using imagery to track motion and correct for wheel slippage in soft terrain. Finally, Spirit was given permission to enter what NASA called deep sleep mode. In this state, nearly all systems would shut down overnight, including heaters, to conserve energy during the cold Martian night. It was a risky move. Without internal heat, one of the rover's most sensitive instruments, the miniature thermal emission spectrometer, could freeze and be permanently disabled. To prepare, Spirit used the instrument one last time, collecting final observations before entering sleep. Then, in the stillness of the Martian dusk, Spirit powered down. It was a gamble for survival, and it worked. Spirit awoke the next morning, older perhaps, but still very much alive. By the time Spirit reached the base of Husband Hill, the Martian landscape had already tested every part of its design, physically, mechanically, and electrically. But now it faced a new challenge: elevation. Husband Hill, named in honor of Rick Husband, commander of the Columbia Space Shuttle, rose over 100 meters above the surrounding plains. From its summit, it promised a broader view of Gusev Crater and perhaps a deeper understanding of Mars's geological past. The journey up would not be easy. Slopes were steep, surfaces were loose, and Spirit's right front wheel was still failing. But the rover and its team were undeterred. Spirit began a cautious ascent, zigzagging along the ridgeline and stopping at frequent intervals to rest, recharge, and analyze the terrain. Along the way, it passed through areas like Tennessee Valley and Cumberland Ridge, places that revealed layered rock outcrops and sand deposits, suggesting episodes of erosion and wind-blown history. Every few meters gained in elevation added not just to Spirit's view, but to its scientific value. Each rock it examined was potentially older, more weathered, and more telling. Spirit was climbing not just a hill, but a timeline toward the past. The environment near the summit became more interesting with every sol. Dark dune fields stretched out across the southern slopes, their wave-like patterns etched by Martian winds. Dust devils occasionally swept through the landscape, and in one miraculous moment, they cleared Spirit's solar panels of months of accumulated dust, boosting its power output dramatically. It was like nature itself had extended a helping hand, giving the rover the energy it needed to continue. This unexpected cleaning event transformed the mission. With renewed power, Spirit pressed on toward the top. On Sol 581, after months of slow, careful driving, Spirit reached the summit of Husband Hill. There, it paused to take a full 360-degree panorama, a sweeping view of the Martian horizon composed of hundreds of individual images. For the first time, Spirit also captured a full image of its own deck. The solar panels, now clean and bright, glistened in the weak sunlight. But the real prize lay just beyond the summit. As Spirit began its descent on the opposite side, it encountered a curious rock, one that would later be known as Comanche. Comanche did not look remarkable at first glance. It was dark and blocky, embedded in a field of similar rocks. But when Spirit analyzed it using its spectrometers, the data astonished the science team. Comanche contained an unusually high concentration of magnesium iron carbonates, nearly 1/4 of the rock's total mass. This was 10 times more than what had been found in any previous sample on Mars. Carbonates are important because they form in the presence of water, but only when the water is relatively neutral, not highly acidic. In other words, Comanche suggested the existence of a more hospitable environment in Mars's distant past. This discovery shifted the narrative. Until then, most signs of past water on Mars had pointed to highly acidic conditions, environments hostile to life as we know it. But Comanche hinted at something gentler, something more Earth-like. Water that could have lingered in underground aquifers, lakes, or even ancient seas. It was not proof of life, but it was proof of possibility. Spirit, battered and aging, had made one of the most compelling discoveries of the entire mission. From the summit of Husband Hill to the mineral heart of Comanche Rock, the red planet was beginning to reveal its hidden history. And Spirit was listening. After descending from the summit of Husband Hill, Spirit began a new phase of exploration, this time directed toward a curious plateau-like formation known as Home Plate. From orbit, Home Plate appeared as a raised circular feature, slightly elevated from the surrounding terrain. Its layered, uneven structure suggested volcanic or sedimentary origins, possibly even hydrothermal activity in the distant past. To the science team, it looked like the kind of formation that might have formed in the presence of explosive water vapor interactions. For Spirit, it was not just another destination. It was a potential window into Mars's active past. As Spirit made its way toward Home Plate, it encountered terrain that was both scientifically rich and mechanically treacherous. On the journey, it rolled over soft soil, rippled dunes, and sharp rock fragments. These would eventually take their toll. By early 2006, disaster struck. Spirit's right front wheel, the same wheel that had been drawing excess current for hundreds of sols, failed completely. It stopped turning. From that moment onward, Spirit was forced to drag the frozen wheel behind it like a dead limb. Progress became slower, every meter of movement carefully planned to avoid stranding the rover. To adapt, The rover team reversed Spirit's driving configuration. It now traveled backward, pulling the failed wheel instead of pushing it. This clever shift in approach minimized resistance and reduced the risk of getting permanently stuck. The change did not just preserve mobility, it led to a stunning discovery. While scraping backward through the Martian soil, the stuck wheel accidentally unearthed a brilliant patch of white silica. This material, usually formed in hot springs or acidic steam vents, suggested a geologically active environment with the potential to support microbial life. Spirit's disability had unexpectedly become a scientific advantage. But Spirit's greatest challenge was yet to come: another Martian winter. With reduced sunlight, the rover's solar panels would not generate enough energy to maintain heat throughout the frigid nights. The original plan was to park Spirit on the north-facing slope of McCool Hill, allowing the panels to tilt toward the low winter sun. But with one broken wheel and increasingly unstable terrain, the hill became unreachable. The team was faced with a difficult decision: keep pushing for McCool and risk immobilizing the rover, or find another safe haven nearby where survival was more likely. That choice led Spirit to a location called Low Ridge Haven, a modest incline offering just enough tilt to collect sunlight during the winter months. It was not ideal, but it was a calculated compromise. Once parked, Spirit shut down all non-essential systems and entered a low-power state. For nearly 8 months, it remained stationary, enduring freezing temperatures and Martian dust storms. During that time, the rover continued to send data, capturing images and monitoring its surroundings. It even identified 2 metallic-looking rocks believed to be meteorites, subtle reminders that Mars, too, is part of a cosmic system filled with collisions and chance. Spirit survived the winter, but not without sacrifice. It had lost mobility in one wheel, faced dangerously low energy levels, and endured months of isolation. And yet, despite all odds, it continued to function, to explore, and to inspire. From the summit of hills to the edge of survival, Spirit's journey was not one of flawless triumphs, but of resilience. It adapted, it persevered, and with every dusty sol, it continued writing the story of a machine that refused to give up, even when every element around it suggested it should. Sometimes, discovery comes not from careful planning, but from failure. In March of the year 2007, as Spirit slowly dragged its broken front wheel across the dusty plains of Mars, something remarkable happened. The crippled wheel, scraping along the surface, unintentionally exposed a patch of bright, almost pure silica beneath the reddish soil. It was unlike anything Spirit had seen before, a white shimmer against the rust-colored ground. To the mission team, it was more than just a strange material. It was a scientific alarm bell, calling for closer investigation. Silica, or silicon dioxide, is a mineral that can form in a variety of environments. But the concentration Spirit found, exceeding 90% purity, suggested a specific origin. On Earth, similar deposits are typically created by hydrothermal systems, such as hot springs or acidic steam vents. In both cases, liquid water interacts with rock, dissolving and redepositing minerals in concentrated layers. The discovery of this high-purity silica hinted that Spirit had stumbled upon the remnants of an ancient Martian environment where water was not only present, but active and possibly long-lasting. To confirm the nature of the silica, Spirit used its full suite of instruments. The alpha particle X-ray spectrometer analyzed its composition, confirming the unusually high silica content. Meanwhile, the microscopic imager provided detailed close-ups of its structure, revealing textures that suggested alteration by water. Scientists back on Earth drew parallels to places like Yellowstone National Park, where hot, mineral-rich waters shape the land and provide niches for microbial life. If a similar system had once existed on Mars, it could have provided a temporary haven for life in an otherwise harsh and frozen world. Though Spirit had not found fossils or direct signs of biology, the discovery of the silica deposit was a powerful clue. It strengthened the case that Mars was once more than just rock and dust. There had been heat, there had been liquid water, there had been chemical energy, all the ingredients needed to support microbial life, at least in theory. Spirit, dragging a broken wheel, had done something extraordinary. It had uncovered not life itself, but the conditions that could have made life possible. It was one of the most important findings of the entire Mars exploration rover mission. And perhaps most poetic of all, this discovery came not from perfect design, but from the rover's own limitation. Had the wheel not failed, Spirit may never have disturbed the soil in just the right way to reveal the buried silica. In that sense, the broken wheel became a symbol of the mission itself, proof that persistence, even when flawed, can lead to revelation. Spirit's journey across Mars was full of planned maneuvers and scientific objectives, but it was moments like this, unscripted, unpredicted, that turned a machine into a legend. By the spring of the year 2009, Spirit had already exceeded every expectation. Designed to last 90 sols, it had endured for more than 5 years on Mars, braving freezing winters, mechanical failures, and towering dust storms. But as the seasons changed once again, and the rover approached another Martian winter, its journey brought it to a deceptively ordinary location. The place would soon be called Troy, a name that, in hindsight, symbolized both a final frontier and a place of entrapment. It was here that Spirit would make its last stand. Troy was not marked by dramatic cliffs or treacherous craters. Instead, it was a gentle depression in the terrain, one that appeared safe for traversal. But as Spirit attempted to maneuver through the area, its wheels began to sink into soft, powdery soil. Unlike the more cohesive surfaces it had previously conquered, the ground at Troy was composed of fine, low-cohesion material, rich in iron sulfate minerals like jarosite. These minerals, while valuable scientifically, made the soil unstable and nearly impossible for Spirit's worn-down wheels to grip. The rover was effectively trapped. The mission team back on Earth launched a full-scale effort to understand and overcome the situation. They recreated the soil conditions at the Jet Propulsion Laboratory, testing different movement strategies with an engineering model of Spirit. Countless simulations were run, commands were carefully crafted, and each small movement on Mars was executed with precision. But nothing worked. Every attempt to free Spirit caused it to sink deeper or placed more strain on its aging wheels. The environment had finally closed in around the rover, leaving it stranded in place. Even though it could no longer move, Spirit was not useless. NASA officially reclassified the mission as a stationary science platform. The rover continued to study its surroundings, sending back valuable data about the composition of the soil, the transparency of the atmosphere, and the effects of shifting sunlight. It took one final panorama, a sweeping image of Troy, with its own tracks frozen in time. Its robotic arm, still functional, carried out soil analysis and instrument tests. Spirit was no longer a traveler, but it was still a witness to the Martian world it had explored for so long. But time and the Martian winter were not on Spirit's side. As temperatures dropped and the sun's angle diminished, the energy collected by its dust-covered solar panels fell below critical levels. By Sol 2195, Spirit was generating just enough energy to keep its internal systems barely alive. One Sol later, it likely entered low-power fault mode, a last resort effort to preserve vital components by shutting down everything else. After that, silence. No signal. No response. Spirit had gone quiet before, but this time felt different. This time, it felt final. NASA continued to send commands for over a year, hoping for a sign of life, a click, a tone, anything. But the Martian night had taken its toll. On May 24, 2011, NASA declared the mission complete. Spirit had covered nearly 8 kilometers, captured over 128,000 images, and rewritten what we knew about Mars. It died not in failure, but in triumph. It had endured beyond all limits and had given humanity a view into another world. At Troy, Spirit came to rest, silent, frozen, and eternal, a monument to exploration, perseverance, and the quiet courage to never stop reaching forward. Long after its wheels stopped turning and its signal fell silent, Spirit's legacy continues to echo, not only through the dusty valleys of Mars, but through the minds of those who dared to explore it. It is easy to measure a mission by kilometers traveled or images taken, but Spirit's true achievement lies deeper. It opened a new chapter in humanity's relationship with another world. It proved that a machine, no larger than a golf cart, could become a storyteller, revealing ancient climates, volcanic histories, and silent whispers of water long gone. Through Spirit's instruments, scientists confirmed that parts of Mars once hosted conditions that could have supported microbial life. It found mineral traces shaped by water, surface textures carved by time, and layered rocks rich with planetary memory. These discoveries reshaped our understanding of Mars as a place that was not always cold and barren, but possibly once warm, dynamic, and alive. Spirit was not a static observer. It was a geologist, a chemist, a pathfinder. Each discovery a brushstroke painting a clearer image of Mars's ancient past. But Spirit's legacy is not scientific alone. It became something more, a symbol, a story told to children and scientists alike. Its endurance through cold winters, mechanical failure, and uncertain terrain reflected the very spirit for which it was named. Across classrooms, museums, and late-night documentaries, Spirit inspired generations who saw in its journey a reflection of their own hopes, that even in silence and solitude, discovery was possible. That sometimes strength lies not in speed, but in persistence. Spirit also redefined how we explore. It marked a turning point in planetary science, a shift from distant observation to on-the-ground investigation. It paved the way for opportunity, curiosity, and perseverance, each of which would stand on the shoulders of its quiet triumphs. Today, when Perseverance rolls across the Jezero crater, it carries more than just instruments. It carries memory. A memory of Spirit's first grind into Martian stone, its first glimpse of sunrise through a dusty lens, and its final panorama, a farewell frozen in light. To commemorate Spirit, the International Astronomical Union named asteroid 27452 Spirit, securing its place in the cosmos it once explored. Its story is no longer just one of data logs and mechanical operations, but of courage and curiosity, the twin forces that define human progress. It stands as a reminder that every rover we send is not just a tool, but an extension of ourselves, sent to wander where we cannot yet follow, to ask questions we are only just learning to frame. And so Spirit rests, not as a lost machine, but as a quiet ambassador of Earth, one that spoke without words, saw without eyes, and moved with a determination far greater than its design. Its journey ended in silence, but its legacy is loud. Spirit belongs to science, yes, but it also belongs to all of us. To those who look up at the night sky and feel something stir inside. To those who believe that no frontier is too distant. To those who still carry a spark of wonder. Spirit showed us what it means to reach for another world, and what it means to never give up once you do. In the end, it was never just about machinery, not just about science or data or dusty wheels dragging across a barren world. Spirit's journey, from Earth to Mars, from motion to stillness, became a quiet meditation on what it means to reach beyond ourselves. It was a mission built on curiosity, driven by perseverance, and ended with grace. A machine that had no heart somehow taught us about our own. As its body lay still on the red sands of Troy, its story lived on, not in the signals it sent, but in the meaning we gave them. That meaning had been written long before the rover ever touched Martian soil. It began with a young girl named Sophie Collis. An orphan once lost beneath cold Siberian skies, Sophie gazed upward at the stars and imagined escape. In her winning essay, she wrote, "It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there." Her words, full of innocence and longing, were chosen to name the rovers Spirit and Opportunity. And in doing so, her voice echoed across the void, carried by a robot that would chase those dreams on her behalf. Spirit, in many ways, was an extension of that dream. It wandered a lifeless world not to escape Earth, but to understand it better, to explore the questions that have haunted our species for as long as we have looked up. Are we alone? Has life ever been elsewhere? Can we survive beyond this pale blue dot? The answers did not come easily. There were no great revelations carved in stone, no messages written in dust. And yet, every rock Spirit touched, every sample it examined, whispered something back. That Mars, too, had a past, and perhaps, once, a pulse. There is something deeply human about sending a fragile machine into the vast unknown, knowing it may never return, knowing it may fail, and doing it anyway. Spirit's journey mirrored our own longing to move beyond boundaries, to test what we can build, and to trust it to endure. Its silence in the end was not a defeat. It was a whisper, fading into a new kind of stillness, one that invites reflection more than applause. Spirit did not shout, it listened. And in listening, it taught us to be more patient with the universe's silence, and more reverent of its secrets. Even now, as newer rovers traverse the Martian surface with more advanced instruments and sturdier wheels, Spirit remains their spiritual predecessor. It is there in every wheel track, every drill sample, every panorama of the alien horizon. It laid the groundwork not just for science, but for a philosophy of exploration, one that says, even the small, even the broken, even the lost can reach greatness. Spirit taught us that resilience is not about having strength, but about continuing forward when strength runs out. And so the story comes full circle. From a child's dream under Siberian skies to a final silent resting place beneath the thin Martian atmosphere. Spirit's mission ended not with fire or failure, but with peace, the kind that comes from a task completed against all odds. The rover stopped moving, but it never stopped meaning something. To this day, it remains a symbol of what we can do when we believe, not just in technology, but in purpose. And when we look up at the night sky, like Sophie once did, we remember, even in the cold, even in the dark, there is always light, and always Spirit. If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.